Hello and welcome to the Demo Fest of the Microsoft Devices and Networking Summit. I'm here with Patrick Baudisch, who is a professor of computer science at the Hasso-Plattner Institute in Potsdam, and Stefanie Mueller, a PhD student of Patrick's. Hello, how are you?
Very well, thanks for having us.
Yeah, thanks.
So before you start with your demonstration, can you tell us a little bit more about the background of this project? How has it come about? What's the context, etc.?
So at Hasso-Plattner Institute, we're working on personal fabrication. We're essentially trying to understand how in the future computer science and mechanical engineering will come together.
Okay, so Patrick, Stefanie, there's some very exciting stuff lying here out on the table, and I wonder, can you tell me a little bit more about it, please?
Yeah, so 3D printing is a really great technology for testing physical prototypes, but one current problem is that 3D printing is actually very slow. So if you want to test a prototype quickly, that's not going to work. You often have to wait hours or even overnight to get your object printed. And this is why we developed the project we are showing in this demo here is called Wireprint. So Wireprint is actually a new printing technique that allows you to save up to 90% of your printing time. And the key idea is that you actually take a 3D model and you convert it to a wireframe representation that represents the overall shape of the object really well. So for instance, if I want to just test this 3D model of a bottle here, I don't have to 3D print everything. I can just convert it to a wireframe, and getting this version here only takes 14 minutes, versus with traditional 3D printing it would take 2 hours.
That sounds really exciting. So the materials you're using, the equipment, is this something that you can currently get in the shops? Is it off the shelf?
So the hardware is off the shelf. We did some minor modifications to get the 3D printing technique running. So the great trick about Wireprint is that it actually does not print layer-wise, which would still be slow. It actually prints like a vector printer, so it prints up and down in a vertical way. And this is actually what makes it so fast. So to print this way, we actually had to quickly to tweak the material parameters, so the heating and the cooling of the machine.
Yes, so Wireprint is one instance of a larger research agenda we have. Directly surrounding this project is a handful of projects in which we're exploring fast 3D printing or fast fabrication overall. The main idea is that I think ultimately, designers may want something like this bottle, which is well designed to fit my hand and fulfill certain properties. But it doesn't mean that in every step of the research, of the design process, I need to have a high fidelity printout, which takes so much time. So we created a series of projects, each of which kind of allow the designer to explore one facet of the design in a very short amount of time, ultimately allowing designers to create or to go through a complete design process in a day, rather than like spreading this out over a week as it takes place right now.
So you talk about fabrication. Can you tell me a little bit more about what challenges fabrication addresses?
Yeah, so this specific kind of research area of low fidelity fabrication we're exploring right now is one instance of just overall a question about speed and interactivity. I think if you look at 3D printing today and related technologies like laser printing, we're still kind of in the very early stages. If you compare this to personal computing, which obviously is a big topic at Microsoft, we're kind of living in the 50s, 60s right now when people carried a stack of punch cards to a computer and then the next day they got some result back. That's the same as if you send something to a 3D printer and wait overnight. I think in the future we're going to have more systems that allow turn taking, where like on a computer, type something in, you get something back. And we're already exploring some projects where we are directly interacting with a fabrication machine and get real-time interaction with that.
So you described some interesting future scenarios there. Can you elaborate a bit further about what that future might look like for the end user, for example?
Well, I think for the end user right now, fabrication started in industry. So it's been in use for a long time in industry. Right now we see the trend where this is happening in the maker communities, so where enthusiasts are using this. And I think ultimately it's something that will hit the end user. And I think there's an interesting analogy to personal computing or to computing overall, which started, when people said the whole world only needs 6 computers, to a point where enthusiasts had them until everyone had them. And I think the potential is very similar, which is the idea of allowing a very broad number of people to solve problems they would not have been able to solve before, in this case mechanical problems. So if you sum it all up, I think what we're at the verge of is seeing a fusion between computer science and mechanical engineering, and this is just the very early beginning of this.
Well, thank you very much, Patrick and Stefanie, for this very interesting demo on fast personal fabrication. I can sort of imagine what a future might look like where users can contribute to the designs of anything. So So next we will see the circuit sticker and conductive nanoparticle ink demo.